Hello, welcome to the Target STEM Walk. We will be targeting 4 different stops today. I'm sure you all have been very eager to learn about the inner workings of the one and only Target, and more importantly, the physics behind some of the most used objects in Target. There are many physics concepts behind a shopping cart. Let's first take a look at the cart's design. Does anyone notice anything about its design that might relate to physics? The handle of the cart is specifically angled. What do you think is the easiest way to push a shopping cart? How would you push the cart? Do you think it would be easier to push the cart parallel to the ground or parallel to the angle handle? It is easier to push a shopping cart parallel to the ground because you minimize the downward force and maximize the force in the X direction, so that the average American shopper does maximum work when the cart is full. When you push the shopping cart at an angle, you're exerting a force downwards that is unnecessary in order to accelerate forward. Target designs the cart handle at an angle, so you exert more force than needed, and subsequently you walk slower, more likely to browse the shelves. At our next stop, we're going to look at the freezer section. Did you know there's a lot of physics in a freezer? Take a second to think about how the motion of particles might relate to the temperature and possible physics concepts. Did you know that some of the food in the freezer isn't completely frozen? Why does the food stored in the freezer not freeze completely but remain cold? We could define temperature as a measure of the average motion energy of particles that make up an object, and kinetic energy is average motion energy. We can conclude that when you cool something in a freezer, the kinetic energy decreases. Grocery stores keep their freezers at a steady 0 degree Fahrenheit to maintain the level of kinetic energy so that the food does not freeze completely, which isn't ideal and efficient when it comes to reheating food. Since we've already talked about the shopping cart, let's get into the grocery basket. Have you noticed that it's easier to swing a Target basket, which only has one handle, back and forth than it is to swing a basket which has 2 handles? Why do you think that is? It is optimal that you can swing your basket in order to evenly distribute the weights of the object that you're placing in your basket, making it easier to carry. And it is easier to rotate the Target basket with one handle because it has one axis of rotation, whereas a basket with 2 handles has 2 axes of rotation, which each require force to be produced in order to rotate. Therefore, with one handle and one axis of rotation, there's less force that needs to be produced. Our last stop is at checkout. The conveyor belts are filled with physics concepts. Think about when you place your food on the conveyor belt and it moves. Do most of your items go rolling all over the place? Usually they don't. Why do you think the items don't roll off the belt? Static friction acts to prevent the belt and objects from sliding across each other. The conveyor belt is accelerating to the right, and if the objects don't match the same acceleration, it will slip. Therefore, static frictional force is necessary for the belt and the object's acceleration to match in the X direction, and therefore able to transport the object across the belt and into the hands of the cashier.